Hello there, it's Lana Tuckey. I've been asked this question about the Math 131 question 4.5, number 28. Of course, it could show up anywhere in your homework. It's number 28 in the actual physical textbook or in the study plan. You can tell that by looking over here in the top right corner. Okay, so I'm going to view an example. I'm going to do the example, which will be very similar to what we have. So it says a growing number of thieves are using key logging programs to steal passwords and other personal information from internet users. The number of key logging programs reported grew approximately exponentially from 0.5 thousand programs in 1999 to 9.0 thousand programs in 2006. Predict the number of key logging programs that will be obtained, or excuse me, that will be reported in 2015. Okay, so what we want to do is we want to make a table of the data that they're giving us. We want to turn that data into points. So obviously we have year and number of programs, right? Key logging programs or whatever. So the year that they gave us was 1999. What we're going to do is we're going to create that another variable, from that. So we're going to actually use a variable t, and I'm going to call that year 0. Right? Because why not? I can call it any year that I want, and I think year 0 makes the most sense. And then in that time, they said it was 0.5, I believe. Let me go back. Yeah, 0.5 in 1999 and 9.0 thousand in 2006. Okay, so it's going to be 9.0 in 2006. Well, if I've set up 1999 to be my starter year, this is actually 7 years later. So this portion of the table is what I'm actually going to use to create my function, because I need to have a function in order to make this work. All right, so now we're going to need to make an exponential function. So I'm going to have number of programs is equal to AB to the t. Okay, so I know what A is. A was given to us by once we created 1999 as our starter year, then 0.5 is your A. It's got to be your starting amount, so 0.5. And then B to the T. Okay, so I don't know what B is, but I do know that I have another point, which is 9.0 equals 0.5, B, I don't know, to the 7. There we go. I can solve this for B. Okay, so again, I'm looking for AB to the T. Oopsie. There we go. All right, so that's what I'm going to do. All right, so now to solve this, we're going to have to divide both sides by 0.5. So let's do that. So 0.5 over here, that's going to cancel, divide, away to 1. And of course, if you do it to the right-hand side, you're going to have to do it to the left-hand side. So over here, you're also going to have to divide by 0.5. So let's take our calculators out. And let's divide 9 divided by 0.5, and we'll get 18. Okay, so 18 equals b to the 7th. All right, now I need to get rid of the 7th power. So what I'm going to do is I'm going to raise both sides to a power that would make the 7 go away. All right, so that power would be, let me put this in the center so you can see it better. There we go. So that power would be the 1/7, right? So I'm going to take the left-hand side and raise it to the 1/7. And I'm going to take the right-hand side and raise it to the 1/7. Now over here, these two divide away, right? They're going to go away. 7 times the 7th, because it's a power to a power, so you're going to multiply. So that's just going to leave you with b. So over on the right, you're going to have b. Over on the left, you're going to have 18 to the 1/7. So let's grab a calculator. 18 caret 1/7. Now, on the new 84s, you can just type 1/7 like that. On the old 83s, if you're stuck with one of those, you're going to have to use parentheses, because otherwise it'll do 18 to the 1 divided by 7, and that is not what you want. So new calculators don't need to bother. If you see the little superscript is what this is called when it writes it up above on top, super, the line, then you don't have to bother. But if you are an old TI-83 calculator and you still see the little caret symbol in there, then you're going to need to use parentheses. All right, so I have the parentheses. It's 1.5112. How many decimal places did they say in the problem? They probably didn't. Nope, they didn't. So let's just do 1.5112. Squiggly equals, because this is not exact here. All right, there we go. Okay, so now that we know this is 1.5112, we now know our equation, which is n, which is the number of key logging programs, is equal to 0.5 times, oopsie, there we go, 0.5 times 1.5112 to the t. Now, none of this is our actual answer. None of it, right? This was just us fiddling around and trying to find some results here. All right, so we still have yet to actually do what they asked, which is to find, what was it, when, predict the number of key logging programs that will be reported in 2015. Okay, so that's quite a bit going on. First thing I have to do is find what year that is. So 2015, take away 1999 as my starter year is 16. So this is my t value here. So I'm going to take t equals 16. I'm going to plug it into the equation. So it was n equals 0.5 times 1.5112 to the 16. And I will find that with a calculator. All right, so clear. 0.5 parentheses 1.5112 close parentheses to the 16. You get 369.9. Okay, so let me put that in. Perfect. All right, so that's our answer. I don't know if they wanted units or not, but it'd be that many programs, right? It'd be 369. It's 1,000, right? Because our unit was in thousands. 1,000 programs. It's key logging programs. All right, so let's go see if I did this correctly, and if I did, then I should match up with what they did. See, they're doing the same thing I was doing. Divide by 9, right? 1.51. I kept more decimals than that, but that's good, and so on. Yeah, you can see down here at the bottom, they said 16 goes to 365.2 or 259, excuse me, and I'm at 369.9. That's not a big difference. That's a little bit of rounding issue because I kept more decimal places than they did. All right, so that's how to do that one. I hope that helps.